Welcome to Brain Vision.
So they're giving us values for an electric turntable. So we have the diameter equals 0.750 meters. And we can immediately say that R is going to be equal to 0.375 meters, rather. And then the initial angular velocity would be 0.25 revolutions per second. And then we can say alpha is equal 0.900 revolutions per second squared. And then they're asking us, okay, what is the final angular velocity after 0.2 seconds? So we can say omega f equals omega I plus alpha t. And this is going to equal, again, 0.255, and then it'll be times 2 pi radians for 1 revolution, plus, and then this will be 0.900, 2 pi radians for 1 revolution, but this will be times 0.2. There we go. And the final angular velocity is going to equal 2.70 radians per second. So this will be your answer for A. For B, they're asking us for the final angular displacement after 2.2 seconds. So theta f equals theta initial plus omega t plus half alpha t squared. This is going to be equal to this is going to be 0, so it's going to be equal to just these two terms. So we have 0.25 times 2. And again, we're not going to be changing to radians because if we keep everything in revolutions, well, the answer will just be in revolutions. So this can equal 0.068 revolutions, and we can just keep it like that. C is asking us for our linear velocity, so v is going to be equal to r omega, and this is going to be equal to 0.375 times our final omega f of 2.7 radians per second, and this is going to be 1.0132 meters per second. At this point, they want us to find the resultant acceleration, so we actually need a new workbook. The A resultant is going to be equal to radical A tan squared plus A radial squared. So we need to find these two values. The tangential acceleration is simply going to be equal to r times the angular acceleration, which is going to be 0.375 times 0.9, and this is going to be 2.737 meters per second squared. And then for the radial acceleration, this is going to be equal to v squared over r, and this is going to be 1.0132 squared over 0.375. And I apologize, this is actually going to be 2.12. Apologize for the computation error. So if this is 2.12 and then this is 2.737, we can solve this. So A resultant is going to be equal to 2.12 squared plus 2.737 squared. And this is going to be equal to 3.462 meters per second squared. So this would be your resultant acceleration for part D. And that's the end of the solution. Thank you for watching.